Hello student, now we are going to discuss another topic in respiratory system, that is mechanics of respirations. So mechanics of respiration means various mechanisms that is responsible for our breathing process, that is inspiration and expiration process. So in this mechanics of respiration chapter, what we are going to learn, first of all we are going to discuss the various pressure system of the respiration, means interpleural pressure, intraalveolar pressure, transmural pressure, all this pressure we are going to discuss. Then we are going to discuss the transmural pressure and lung volume, how they are related. If you change the transmural pressure, how the lung volume, chest wall volume, they are going to change. So that we are going to discuss. And then we are actually going to discuss the mechanisms of respiration, that is mechanism of inspiration and mechanism of expiration. And at the end, we are going to discuss few MCQs from this session. So this is our plan. So now let's start with the first one, that is the various pressure system of the respiration. Now, various pressure system, to understand this concept of pressure system in the respiration, first of all you understand what is the resting condition of the respiration. So resting condition means if you hold your breathing for some times, then that condition is the resting condition of your respiratory system. So breathe holding. But thing is that when you will hold your breath at the end of deep inspiration, suppose I am taking a deep inspiration like this and then I am holding. So my respiratory system is at stop. Okay, that is the resting condition, but is that the resting condition at the end of inspiration? No. So I can hold my breath also at the end of forceful expiration, but that is also not resting condition. But if you hold your breath at the end of, so if you hold your breath, so holding of breathing, this is very important, holding of breathing at end of normal expiration, right? So please note down that the resting condition of the respiration means if you hold your breath at the end of quiet breathing, at the end of normal expiration, then that condition is known as the resting condition of the lung. So if I ask you, if you hold your breathing at the end of normal expiration, what are the volumes that still remain inside your lungs? So we all know that if you hold your breath at the end of forceful respiration, residual volume will always remain inside your lung. But if you hold your breath at the end of normal expiration, then apart from residual volume, the expiratory reserve volume will also stay inside your lung. So combination of these two is known as the functional residual capacity, or FRC. So FRC is known as the resting lung volume. So this is one of the first MCQs that you have to remember, that resting condition of the lung means if you hold your breath, if you stop your breathing at the end of normal expiration, then that condition is known as the resting condition of the lung, right? So expiration, after end of normal expiration. So in this condition, what volume is staying inside your lung? Two volume, residual volume and expiratory reserve volume. So combination of these two volume is functional residual capacity. So that's why functional residual capacity is resting lung volume or resting condition of the lung. Got it? Okay. Now suppose this diagram which we have already made here, suppose this is the representation of all the alveoli in your lung, and surrounding this alveoli, this is the visceral pleural covering. So this is the visceral pleura covering the alveoli, all the alveoli which are present in the lung. So suppose this lung is at resting condition, means this lung is at FRC volume. So FRC is present inside this alveoli and the person is holding his breath, right? So in this condition, you know, all the alveoli, they are surrounded by elastic tissues. So this alveoli, they are surrounded by elastic tissues, and these elastic tissues are connected with the visceral pleura by some elastic septum, right? So these are the elastic septa which are connecting this elastic tissue of the lung with that of the visceral pleura. And if you know that the recoiling tendency of this elastic tissue is in inward direction, then you will be able to understand that this elastic tissue which is surrounding the alveoli, they will try to cause collapse of the whole lung. They will try to cause collapse of the alveoli. So what I am saying, so this elastic tissue which is surrounding this alveoli of the lung, they have an inherent tendency to recoil in the inward direction. So this arrow indicates this recoiling tendency of the elastic tissue in the inward direction. And if this alveoli is recoiling in the inward direction, so obviously the visceral pleura will also pull with that of this elastic tissue of the alveoli. That means this elastic recoiling of the lung tissues, they have an inherent tendency to cause collapse of this alveoli. But we normally know that if you hold your breath at the end of normal expiration or at FRC, alveoli is not going to get collapsed. Okay, not only the FRC, it at any volume, if you hold your breath, your alveoli is not going to get spontaneous collapsed. So who is preventing this collapse of this alveoli? So someone has to hold this alveoli open, right? So what is the system behind that? So look at, so not only this visceral pleura which is surrounding this alveoli, we also know that there is also a parietal pleural covering surrounding this lung. So suppose this is the parietal pleural covering surrounding this lung, right? And this parietal pleura, they are attached with the chest wall. We all know that this parietal pleura, they will remain attached with the chest wall. So this round shaped diagram that I am drawing here, this is nothing but the chest wall, right? So this is the cross section of the ribs and this is the muscles in between. Okay, so this is the intercostal muscles in between. So this black color diagram that I have just made here, so this is representing the chest wall. Now this chest wall remain attached with this parietal pleura. And chest wall also contain elastic tissue. The muscles which are present in the chest wall, the bones which are present in the chest wall, the cartilage which are present in the chest wall, including the tendons of the muscle, all of them are elastic tissues. And the elastic recoiling of the chest wall has an inherent tendency to recoil back in the outward direction. So what I am saying, this elastic tissue of the chest wall, they have a tendency to recoil back in the outward direction. Just before this, we already discussed that the elastic tissue of the lung has a tendency to recoil in the inward direction, right? They are trying to cause collapse of this alveoli. And now just we talked that this elastic tissue of the chest wall, they have an inherent tendency to expand in the outward direction or elastic recoiling in the outward direction. So visceral pleura along with this lung, it has a tendency to recoil in the inward direction, and the parietal pleura along with the chest wall, it has a tendency to recoil in the outward direction. So both the pleura, okay, visceral and parietal, both of them are recoiling but in opposite direction. Okay, lung is pulling the visceral pleura in the inward direction and chest wall is pulling the parietal pleura in the opposite direction. And in between these two pleural space, we all know that little amount of fluid is present. So in between this pleural space, little amount of water is present, and that is known as the interpleural fluid. We all know that this interpleural fluid has a volume of 10 to 20 ml. So this has also been asked in MCQ, so try to remember this number, 10 to 20 ml. So what is going to happen? So we are trying to understand that we have two pleura. So okay, so one is the visceral pleura and another one is the parietal pleura, right? So suppose this is the parietal pleura and this is the visceral pleura. And this interpleural space, it's a closed space. There is no opening into this space, and in between these two pleural space, there is little amount of water, very little amount of water, which is present in between this visceral and parietal pleura. And we have already discussed that this visceral pleura has an recoiling tendency to the inward direction and parietal pleura has an recoiling tendency in the outward direction. So normally, when this elastic recoiling pull is not there, these two pleura, they will remain attached with one another. So these pleura are very thin membrane, right? This thin membrane, they remain attached with one another, and in between these two membrane, there is a little amount of water, moisturization. So what will happen? This water will act as a glue, as if these two membrane, they are attached with one another. But whenever you are pulling the visceral pleura in one direction and parietal pleura in opposite direction, what will happen? There will be creation of a space in between these two pleura. Right. So normally they attached with one another, there is no space in between. So when there is no space in between, what will be the pressure in this space? Obviously space is not there, so the zero pressure is zero. But whenever the visceral pleura is pulled by the lung tissue in one direction and parietal pleura is pulled by the chest wall in the opposite direction, so there will be creation of a small space in between two pleura. What will happen to the pressure of this space? So we all know that this is a closed space. So inside this closed space, the Boyle's law will be applied, that is PV equal to constant. So whenever you are increasing the volume of this pleural space, what will happen to pressure? The pressure will reduce. So normally when two pleura was there was no pull, so pressure was 0. Now whenever you are pulling these two pleura in opposite direction, there will be dropping of pressure. Dropping of pressure means it will be below 0 millimeter of mercury, and below 0 millimeter of mercury means what will happen to the pressure? The pressure will be negative. That's why we say that the pressure inside this pleural space, that is known as the intrapleural pressure, which is also known as the intrathoracic pressure. Okay, intrathoracic pressure or intrapleural pressure, this pressure is negative. Just now we understood what is the cause of this negativity. So I am writing here, this is very, very important, that intrapleural pressure is a negative pressure, negative pressure. So what is the cause of this negativity? Why this pressure is negative? Because of the elastic recoiling of the lungs is opposite to the elastic recoiling of chest wall. So this is opposite to the elastic recoiling of chest wall, and because of this opposite pulling, what is happening? The interpleural pressure is becoming negative. Getting my point? So please note down that the intrapleural pressure is negative, and why, how this negativity is created? Because of the elastic recoiling of the lung and chest wall in opposite direction. Now at FRC, these two forces, this elastic recoiling of the lung tissue, as well as the elastic recoiling of the chest wall, both of them are equal to one another. This pressure is equal to one another at which lung volume? At FRC. That's why we say that FRC is the resting condition of the lung, because in this condition the elastic pulling of the lung is balanced by the elastic recoiling of the chest wall, and because both of these forces are balancing one another, this is the resting condition or relaxation condition of the lung. So that's why we say that if you hold your breath at the end of normal expiration, that is the resting condition, that is the relaxed condition of the lung, because in this condition the elastic recoiling of the lungs tissue is exactly equal to the elastic recoiling of the chest wall, and they are opposite to one another. And because of this opposite pressure, just now we have understood that this intrapleural pressure is negative. Now if I ask you how much negativity this is, what is the actual interpleural pressure, your answer will be minus 2.5 millimeter of mercury or minus 5 centimeter of water. So please try to remember both of these units. Sometimes the question is asked in millimeter of mercury unit, sometimes the question is asked in centimeter of water pressure. So minus 2.5 millimeter of mercury or minus 5 centimeter of water. So this pressure is negative pressure, intrapleural pressure is negative. So just now we have understood that how this negativity is created. The elastic recoiling of the lung and chest wall, they are opposite to one another, right? That's why the negativity is created. Now I told you already that this interpleural space contains little amount of fluid, that is 10 to 20 ml. If you ask me that what is the source of this fluid set, please remember that the capillaries which are there at the level of parietal pleura, they are going to secrete this fluid into this interpleural space, and the lymphatics which are there at the visceral pleura, they are going to drain out this fluid from the interpleural space. So there is a continuous process. Secretion is going on from the capillaries in the parietal pleura of the lung, and the drainage of this fluid is done by lymphatic of the visceral pleura. Now if you look at the net force of fluid secretion at the capillaries of the parietal pleura, so what is the net force with which the fluid is secreted? The net force is 9 centimeter of water. What is this net force we are thinking of? This is the net force calculated by the Starling force formula that we have already learned in renal physiology. So the net force with which the fluid is secreted into the interpleural space is 9 centimeter of water, but the net force with which the lymphatics takes out the fluid from the interpleural space is 10 centimeter of water. So now you are understanding that secretory fluid force and the reabsorption fluid force is more. So what will happen? Secretory force is there and reabsorption force is there. Reabsorption force is more than that of the secretory force. So this lymphatic drainage will also create a little negativity inside the interpleural space. That's why we say that although that this negativity is created by the elastic recoiling of the lung and chest wall, but this negativity is maintained okay, by lymphatic drainage of visceral pleura, lymphatic drainage of visceral pleura. Okay, suppose the lymphatic drainage visceral pleura. Suppose the lymphatic drainage is blocked at the level of visceral pleura due to some tumor or due to some cavities. Okay, so what will happen? Obviously, you know that fluid is continuously going to be secreted from this capillary, and the fluid will be accumulated in the interpleural space. If the more fluid is accumulated in the interpleural space, then this negativity is not going to be there. The fluid will create the positive pressure. That's why we all know that this constant drainage by the lymphatics from the visceral pleura is also required to maintain the negativity of the interpleural space. So, the negativity is created by elastic recoiling of the lung and chest wall. I am repeating constantly because this is an important concept, and maintenance of the negativity is done by lymphatic drainage of the visceral pleura. Right. Now, I told you earlier that this, if you allow this alveoli to remain alone without the chest wall, what will happen? The alveoli will get collapsed because it has an inherent tendency, the elastic tissue which are there, it has an inherent tendency to get collapsed. So, I told you that someone has to hold this alveoli open. Who is going to hold this alveoli? This negative pressure which is there inside this interpleural space, this negative pressure is going to hold this alveoli open. So, because the interpleural pressure is negativity, what is the advantage of this negative pressure? So, the advantage of this negative pressure is that this negative interpleural pressure, it holds the alveoli, it holds the alveoli in open condition, otherwise the alveoli will get collapsed. So, the interpleural pressure, how it is getting negative, how the negativity is created, we have discussed. How the negativity is maintained, that we also have discussed. Now, we are discussing that what is the advantage of this negativity. The advantage of this negativity is that this negative pressure, interpleural pressure, is holding the alveoli open. Negative pressure means if I create negative pressure surrounding your body will expand, and positive pressure means it will cause compression. So, this negative interpleural pressure is keeping the alveoli open. If this negative pressure is not there, suppose the negative pressure is becoming positive or the negative pressure is becoming 0, then the alveoli are going to get collapsed. Okay, you will understand. We will take one clinical example, but before that, try to understand. So, when the lung is at FRC volume, that is the resting lung volume, in that condition, the intrapleural pressure is negative, and that is minus 2.5 millimeter of mercury or minus 5 centimeter of mercury. In this same resting condition, if you calculate the pressure inside this alveoli, so in the same condition, if I calculate the pressure inside this alveoli, that is known as the intra-alveolar pressure, and intra-alveolar pressure will be how much? So, look at, so lung is in resting condition, the interpleural pressure we have already discussed in negative condition. Now, the alveoli, this alveoli is open in the atmosphere. So, whenever any space is open in the atmosphere, we all know that there will be equilibrium of pressure between this alveoli and the atmospheric pressure. So, atmospheric pressure is how much? We all know that the atmospheric pressure, ATM pressure, is 760 millimeter of mercury. Because the alveoli is constantly open in the atmosphere, so the alveolar pressure will be same to same with that of the atmospheric pressure, means 760 millimeter of mercury. So, this 760 millimeter of mercury pressure, we are going to write it as 0 millimeter of mercury. So, if I ask you that what is the normal intra-alveolar pressure, you will answer that said normal intra-alveolar pressure is 0 millimeter of mercury. So, what do you mean by this 0? 0 means it is absolute 0 pressure, answer is no. In respect to atmosphere, in relative to atmosphere, so this pressure 0 pressure means this is basically 760 millimeter of mercury. So, whenever we are using the 0 pressure, that means this is a relative pressure relative to the atmospheric pressure. If the pressure is same to same with that of the atmospheric pressure, then that is 0. If the pressure is below than that of the atmospheric pressure, then that is negative. If the pressure is more than that of the atmospheric pressure, then we will write down that the pressure is positive pressure. Getting my point? So, all the pressure system that is generally described in books are the relative pressure system. It is not the absolute pressure, relative in comparison to the atmospheric pressure. If it is same to same with that of the atmospheric pressure, then we are going to write down 0 millimeter of mercury. So, we have already discussed that the intrapleural pressure is minus 2.5 millimeter of mercury. I can also write that the intrapleural pressure is plus 2.5 millimeter of mercury, but that is absolutely wrong, but I am using the word plus 2.5 millimeter of mercury subatmospheric. Getting my point? So, now whenever I am using this term subatmospheric, I have already used the negative term. Getting my point? So, whenever I am using this word subatmospheric pressure, it means it's a negative pressure. So, either you use this negative sign or you use the subatmospheric pressure, because just now we have discussed that all the pressure system in the respiratory system are the relative pressure. Relative pressure means relative in comparison to atmosphere. So, if the pressure is below than that of the atmospheric pressure, then we will use the sign negative. If the pressure is more than atmospheric pressure, we will use the sign positive pressure. Got it? So, bottom line is that at resting condition of the lung, okay, intrapleural pressure is minus 2.5 millimeter of mercury, that is lesser than that of the atmospheric pressure. So, actual interpleural pressure will be how much? So, actual interpleural pressure will be 760 minus 2.5. So, that is the actual interpleural pressure, but normally we are using minus 2.5, that is the subatmospheric pressure. Got it? And interalveolar pressure is how much? 0 millimeter of mercury. Now, I told you that this intrapleural pressure, because it's a negative, we have an advantage. And what is that advantage? Alveoli remain open. So, we will take one example, that suppose there is a pneumothorax. So, what is going to happen, right? So, we will understand what is the utility of the negative interpleural pressure with these examples. Okay. So, look at this diagram. So, this is the same diagram. This is the representation of the alveoli. This is the visceral pleura and this is the parietal pleura. Now, suppose this patient is suffering from an injury to the chest wall, and because of the injury to the chest wall, there is an opening here. There is an opening at the chest wall. So, whenever there is opening, we have already seen that the pressure inside this interpleural pressure, that pressure is a negative pressure. Negative means that is below than that of the atmospheric pressure, minus 2.5 millimeter of mercury, negative pressure. So, negative pressure means this is lesser than that of the atmospheric pressure. So, whenever there is an opening at the level of chest wall, what do you think? The atmospheric air is going to enter inside this interpleural space, or the air will go out of this interpleural space? What do you think? Obviously, the outside atmospheric pressure air has a more pressure than that of the interpleural pressure. So, atmospheric air is going to enter inside this interpleural space, and we all know that whenever air enter inside this interpleural space, we know that there is a little amount of fluid, but if this fluid is replaced by this atmospheric air, then that condition is known as the pneumothorax, right? Pneumothorax. Now, I am asking you that how long this atmospheric air will continue to enter. So, what is the pressure of this atmospheric pressure? The 760 millimeter of mercury. Whenever more and more air is entering in this interpleural space, the pressure is going to increase gradually, and ultimately, whenever inside pressure, that means interpleural pressure, becomes 760 millimeter of mercury, then that condition, the atmospheric pressure and the interpleural pressure, both pressure is same. That means that is the point where no further entry of atmospheric air is possible. That means, in this case of pneumothorax, whenever the intrapleural pressure is 0 millimeter of mercury, interpleural pressure is 0 millimeter of mercury, in that condition, the air entry will be stopped. And this 0 millimeter of interpleural pressure means what is going to happen for the alveoli? The alveoli are going to get collapsed. The alveoli are going to get collapsed. So, that's we all know that in case of pneumothorax, okay, so whenever air enter into the interpleural space, okay, that is typically known as the simple pneumothorax. So, if I ask you that in case of simple pneumothorax, what will be the intrapleural pressure? Your answer will be intrapleural pressure will be 0 millimeter of mercury. If the interpleural pressure is 0 millimeter of mercury, do you think the alveoli will remain open? Answer is no. Already alveoli has a tendency to get collapsed. So, you require a negative pressure to hold the alveoli open. Whenever the pressure is 0, the alveoli are going to get collapsed. Got it? Okay. Now, there is another kind of pneumothorax when that is known as the tension pneumothorax, right? So, in case of tension pneumothorax, you know what happens? Tension pneumothorax means in this condition, there will be certain kind of laceration injury to the lung, and because of the laceration injury, what happens? There will be a gap in this visceral pleura. There will be a gap in this visceral pleura, okay, and this gap, okay, there will be a flap-like valve in this gap. Flap-like valve in this gap. So, what will happen? Whenever the person will take inspiration, the air will enter from this atmosphere into this alveoli, and from there through this gap the air is going to enter in the interpleural space. So, during inspiration the air is entering in the interpleural space, which is not a normal phenomena, but because of the gap, because of the injury to the visceral pleura, the air is entering. But whenever the person will expire, this valve will get collapsed here. Getting my point? So, there is an opening, there is a creation of a valve-like phenomena at the visceral pleura. This valve will opening in case of inspiration, but during the expiration this valve is getting closed. The valve is getting closed. So, what will happen? Whenever the person will take inspiration, more and more air is going to enter into the interpleural space. Okay, but during expiration the air is not going to get out of this interpleural space. So, what will happen? More you take inspiration, more the patient will take inspiration, more air will enter in the interpleural space, and gradually the interpleural pressure will be 0 first, and then it will be positive. Positive means more than that of the atmospheric pressure. So, that is why we know that tension pneumothorax means, why the word is tension, because in these cases there is generation of the huge tension inside the interpleural space. Normally interpleural pressure is negative, but in these cases interpleural pressure is positive. What do you mean by positive pressure? Interpleural pressure positive means it is a compression force on alveoli. So, alveoli already has a tendency to get collapsed. Now, in this tension pneumothorax, because the interpleural pressure is positive, this positive pressure will put additional force, and that will be helpful for the collapse of lung. And that is why we know that tension pneumothorax is an emergency condition where severe large collapse can happen in the lung. Maybe a whole lobe of the lung get collapsed. Okay, so that's a medical emergency. And what is the treatment of the tension pneumothorax? You all know that you have to make one large bored needle, you have to enter one, you have to make a puncture in the second intercostal space with a large bored needle. Whenever you make a puncture, inside interpleural pressure is very high, that is more than atmospheric pressure. So, what will happen? The extra amount of air will go out. Okay, so tension pneumothorax, if you puncture in the interpleural space, the excess air which is there in the interpleural space, that will come out of the interpleural space. Getting my point? So, that is the treatment, that immediately you have to put one puncture in the second intercostal space. So, now with this concept you are understanding that what is the utility or advantage of the negative interpleural pressure. The interpleural pressure negative means the alveoli will remain open. Even if become 0, then also alveoli can get collapsed, and if it is positive, then obviously the alveoli is going to get collapsed. Okay, so this is simple pneumothorax and tension pneumothorax examples. Now, after understanding this intraalveolar pressure and interpleural pressure, now we are going to discuss transmural pressure concept. So, transmural pressure, whenever we use this word transmural pressure, it means the pressure difference across certain structure, pressure difference across one wall. Suppose this is a structure or this is a wall. Okay, it may be membrane, it may be anything, it may be tissue, anything. If you measure a pressure difference across this wall, okay, on the both side of this wall, okay, then that pressure is known as the transmural pressure. Okay, getting my point? So, across an wall, across an structure. So, in respiratory system, we have to understand 3 different types of transmural pressure. First one is the transpulmonary pressure. So, if you measure a pressure difference between intraalveoli, so difference of pressure between intraalveoli, inside the alveoli, and intrapleural space. Okay, so I am taking a pressure difference between alveoli and interpleural space, in minus out. Okay, so what I am going to do? So, transpulmonary pressure means this is equal to intraalveolar pressure minus intrapleural pressure, always in minus out, right? That is transpulmonary pressure. Why transpulmonary pressure? Try to understand. So, in between this intraalveoli and interpleural space, which tissue is present in between these two space? So, this whole lung tissue is present in between these two space. Whole lung tissue means the pulmonary tissue is present if you measure a pressure difference between alveoli and the interpleural space. So, what is the structure which is present in between alveoli and your interpleural space? Your lung tissue is present, your pulmonary tissue is present, and that is why the word is transpulmonary pressure. So, the across the wall, the structure which is present in case of intraalveolar minus interpleural space, the structure or the wall which is present in between them is nothing but the pulmonary tissue. That's why this pressure difference is known as the transpulmonary pressure. So, I am putting here. So, if you make a pressure difference between these two, this is A. A means this is transpulmonary pressure. So, if I put the normal value of this, intraalveolar pressure in resting condition is how much? That is 0 millimeter of mercury, we have just discussed, minus intrapleural pressure. Intrapleural pressure is minus 5 centimeter of water, we have already discussed this. So, 0 minus 5 centimeter of water. So, how much this will be? Plus 5 centimeter of water. Please try to understand. This is simple mathematics, in minus out. You put what is the pressure inside, you put what is the pressure outside, and you subtract them, and that is your trans pressure, right? So, transpulmonary pressure we just understood. Now, the second type of pressure is the transthoracic pressure. So, from the name you can predict that if you take a pressure difference between intrapleural pressure and outside the chest wall pressure. So, intrapleural and outside chest wall. So, in between these two structure, we have already seen that this chest wall is there. So, the chest wall, that is the cross section of the ribs and the cross section of the muscle. So, this chest wall is present, okay. Here is the chest wall. So, if I make a pressure difference, if I measure a pressure difference, I will take a different color. Just hold on. So, this is the structure, okay. So, if I take a pressure difference between this intrapleural space, okay. So, this intrapleural space and the chest wall, outside chest wall. So, in between these two, the pressure is B. What is B? The transthoracic pressure. So, I can easily understand that if you take a pressure difference between interpleural space and outside the chest wall, in between these two, there is the presence of the thoracic wall or chest wall. So, that is why here the wall is the chest wall, and you are measuring the pressure difference inside the chest wall, outside the chest wall, inside the chest wall, outside the chest wall. So, that is why this is known as the transthoracic pressure. So, the transthoracic pressure is equal to intrapleural pressure minus chest wall pressure, chest wall pressure. So, the pressure which is there on your chest wall is nothing but your atmospheric pressure, okay, atmospheric pressure. So, intrapleural pressure is minus 5 centimeter of water, okay, minus chest wall pressure is 0 millimeter of water. So, this is nothing but minus 5 centimeter of water. So, transthoracic pressure, just we have discussed, transthoracic pressure is minus 5 centimeter of water. Transpulmonary pressure is plus 5 centimeter of water. And the third one, the last one or the third one is the transrespiratory pressure. So, if you take a pressure difference between intraalveolar and the chest wall, outside chest wall pressure. So, I am measuring a pressure difference between intraalveolar pressure and the outside chest wall pressure. So, I am writing here transrespiratory pressure means intraalveolar pressure minus chest wall pressure or the atmospheric pressure. So, both of this pressure is 0. So, that is why this pressure will be 0 millimeter of mercury, transrespiratory pressure. So, in these cases, if you look at, you are measuring a pressure difference between alveoli and outside chest wall. In between, your pulmonary tissue is also there, in between your interpleural space is also there, in between your thoracic wall is also there, means all component of the respiratory system is present in between these two space. That is why the wall, okay, if you measure a pressure difference between intraalveolar and chest wall pressure, in between these two pressure zone, there is whole respiratory system is there, whole component of the whole respiratory system is there. That is why the word is used the transrespiratory pressure. So, getting my point? So, these three transmural pressure you have to understand. Okay. So, now after understanding these three transmural pressure, we are going to understand that if you change this transmural pressure, how the lung volume or how the chest wall volume is going to change. Okay. So, now this schematic diagram we have already discussed. So, here is the representation of the whole alveoli along with the visceral pleura and the parietal pleura. So, lung and chest wall both are intact. So, in this diagram, so lungs plus chest wall, all of them are intact. Okay. Why I am using this word intact? Because you will understand a little later. So, lung and chest wall, all of them are intact. In this condition, when this system is at FRC, we have already discussed what is the meaning of FRC. So, when the system is at FRC, that is the resting condition of the lung. So, what we have discussed in resting condition of the lung means the elastic recoiling tendency of this alveoli or the elastic recoiling tissue of the lung has an equal and opposite elastic recoiling of the chest wall, that we have already understood. So, in this condition, when the lung and chest wall are intact, both of them are intact, if I measure a pressure difference between this intraalveolar zone and the chest wall zone, what is the name of this difference of pressure between these two zones? This is known as the trans-respiratory pressure. So, in resting condition of the lung, when the volume inside the lung is FRC, if I measure a trans-respiratory pressure, okay, trans-respiratory pressure. So, what will be the value of the trans-respiratory pressure? Lung is in resting condition. What is the intraalveolar pressure? 0. What is the chest wall pressure? 0. So, the difference between 0, 0, 0 is 0. So, trans-respiratory pressure is 0 millimeter of mercury, means bottom line is that when lung and chest wall both are intact, means normal condition of our lung and chest wall. In this condition, when the trans-respiratory pressure is 0, how much volume is present inside this lung? The volume is known as the FRC. Got it? That is what is FRC? What is the resting condition of the lung or relaxation volume of the lung? So, now we are going to draw this in some graph. Okay, whatever we have understood so far, you will understand. Okay. So, now we look at this. So, this is the x-axis I have already made and this is the y-axis. So, y-axis we are going to plot the volume. Which volume? Volume of the lung, volume of the chest wall, all this volume we are going to plot. And x-axis is the pressure. X-axis is the pressure. So, this is also pressure. Okay. And this is the 0 point. Now, if I take trans-respiratory pressure, so when the trans-respiratory pressure is equal to 0, tell me what will be the volume of the lung and chest wall? Just now we have discussed. When the trans-respiratory pressure is at 0, what is the volume of the lung and chest wall? That is the resting volume. What is that? FRC. So, all this line that already been plotted here, suppose this is your FRC volume, this is your TLC, that is the total lung capacity volume, this is the residual volume, minimum volume in normal condition. So, when the trans-respiratory pressure is 0, the volume of the lung and chest wall is at FRC. Now, if I increase the trans-respiratory pressure, so if I increase the trans-respiratory pressure means you are giving pressure from this, okay, you are giving pressure from this. So, whenever you give positive pressure from the alveoli, so what is going to do? It is going to cause expansion of the lung and chest wall. And if this trans-respiratory pressure is negative, what is going to happen? The lung and chest wall, they are going to get compressed. Getting my point? Understanding? So, the trans-respiratory pressure is 0 millimeter of mercury. The volume of the lung and chest wall is at FRC. Getting my point? But whenever the trans-respiratory pressure is in positive direction, there will be expansion, there will be increase in the volume of the lung and chest wall like this. And if you causes negative pressure, negative trans-respiratory pressure, then the lung and chest wall volume is going to decrease. And how much minimum decrease in possible? That is up to residual volume. So, from this graph, what is you are understanding? That this blue color curve, this is the curve of the lungs plus chest wall. Both of them are intact. So, when the lung and chest wall is intact, the resting volume or the relaxation volume is at FRC. The maximum volume that can reach is up to TLC and the minimum volume that you can reach as FR, that is residual volume. Getting my point? So, this is the graph of the lung and chest wall. Now, you are understanding that why we are saying lung and chest wall again and again. Look at. So, now from this diagram, suppose I am removing the chest wall. So, what I am doing now? Now, I am removing chest wall. So, obviously, this is an experimental condition. If you remove the chest wall from this structure, lung and chest wall, both of them are there, but now you are removing the chest wall. So, only lung is there. So, only lung is there, only lungs tissues are there. So what is going to happen? What will happen to the lung if you remove the chest wall? Just now we have understood that even if there is an opening in the chest wall, simple pneumothorax will be created. In that cases also the lung may get collapsed. So whenever you remove the whole chest wall, the lung is open in the atmosphere. So inside the elastic tissue has a tendency to recoil tendency, and outside pressure is not negative pressure, outside pressure is zero pressure. So it will causes compression on the alveoli and all the lung is going to get collapsed. So whenever only lung is there, we all know that the lung is going to get collapsed. There will be full collapse of lungs. So when the lungs are fully collapsed, what will be the volume inside the lung? So this is now a peculiar question. So suppose this is the diagram of the collapsed lung. So when the lungs are fully collapsed, remember the volume inside the lung is not 0 ml. There will be little amount of volume which still remain inside the alveoli. Why? Because you know, whenever whole lung is going to getting collapsed, there will be closure of the smaller bronchioles. There will be closure of the smaller bronchioles even before the complete closure of the alveoli, even before the complete collapse of the alveoli. So alveoli and bronchiole all are going to get collapsed. But what will happen? The smaller bronchioles, they are going to get collapsed even before the full collapse of the alveoli. So that's why there will be little amount of volume which will still remain inside the alveoli. So this volume which is still remain inside the alveoli even after full collapse is known as the minimal volume, not the minimum volume. So this is very important, had been asked in AIIMS entrance examination. So the volume which is still remain inside the lung is known as the collapsed lung, is known as the minimal volume, and approximately you know the value of the minimal volume, that is 500 ml. So what is the value of residual volume? We know 1200 to 1300 ml, okay, and here this is only 500 ml. So the minimal volume which will still remain inside the lung is 500 ml. Got it? So when only lungs are present, the lungs are going to get collapsed. When the lungs are fully collapsed, the volume which is still there inside the lung is 500 ml or minimal volume. In these cases, if I measure a pressure difference between alveoli, intraalveoli and outside atmospheric pressure, what will be the name of that pressure difference? So that you are measuring the pressure between alveoli and outside the alveoli, so outside in the atmospheric pressure. So in between these two pressure zones, so alveoli and outside, in between these two pressure zone, which structure is present? Pulmonary tissue is present. So this pressure will be known as the transpulmonary pressure, and transpulmonary pressure will be how much? That is 0 millimeter of mercury, because inside pressure, outside pressure both are same, and that's why there is full collapse. So when transpulmonary pressure is 0 millimeter of mercury, in this condition, the volume which will be stay inside the lung is 500 ml. So we are going to plot this same condition. So here now the x-axis will be the which pressure? The transpulmonary pressure. So when the transpulmonary pressure is 0 millimeter of mercury, when the transpulmonary pressure is 0 millimeter of mercury, what will be the volume of the only lung? That is a minimal volume. And what is that? That is approximately, so this is minimal volume, so that is approximately 500 ml. Now if you causes positivity, now suppose you are increasing the positivity of this transpulmonary pressure, so what will happen? The lung is going to get expanded, obviously, okay. So lungs are fully collapsed, but if you causes positive transpulmonary pressure, so positive pressure means it will open up the alveoli and alveoli are going to expand. So from this minimal volume pressure, if the transpulmonary pressure is getting more and more positive, the lungs are going to get expanded. But if there is more and more negativity of this transpulmonary pressure, further decrease in the volume of the alveoli or lungs is not possible, because I already told you that minimal volume is that condition where bronchioles are fully collapsed even before the full collapse of the alveoli. So even if the bronchioles are already collapsed, the remaining air which is there inside your alveoli, they are not going to go out, right? So that's why. So look at this red color curve. So this red color curve is plotted for only lungs. So when only lungs are there, the minimum volume that is possible is the minimal volume, that is 500 ml. And from there, if the transpulmonary pressure is positive, there will be expansion of the lung, and if the transpulmonary pressure is negative, no further decrease in the volume of the lung is possible. Got it? Okay. So, what is the zero transpulmonary pressure means? Zero transpulmonary pressure means there will be only 500 ml of air in the alveoli or lung, that is known as the minimal volume. Got it? Okay. So, from this FRC, we have moved to one extreme condition that you remove the chest wall. Now, we are going into the opposite extreme condition. What is that opposite extreme condition? Now, you remove the, okay, now you removing the lungs, removing the lungs from the chest wall. So, if you just remove the lung from the chest wall, okay, so lung and chest wall is intact. In an experimental animal, you are taking out the lungs tissue from the chest wall. So, only chest wall is there. What we have already discussed, the elastic tissue of the chest wall, they has an inherent tendency to move in the, to expand in the outward direction. So, without lung, so when only chest wall is there, so when only chest wall, only chest walls is there, what will happen? There will be expansion of the chest wall. So, the chest wall is going to get expanded more and more. So, chest wall is going to get expanded. So, this is the expansion of the chest wall. So, if you remove the lung from the chest wall, what will happen? The chest wall will go on expanding. But go on expanding means how much? You will go on expand up to infinity? Answer is no. Obviously, there is a limit. So, it will go on expanding, 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 and then it will stop expanding further. So, that is the resting condition of the only chest wall. So, chest wall will go on expanding, expanding, expanding. The volume of the chest wall will expand, but whenever the volume inside this thoracic cavity or the chest wall is 70% of the TLC, total lung capacity, 70% of that, that is the condition where chest wall will stop expanding further. Means this is the condition where the expansion of the further expansion of the chest wall will be stopped, and this is the resting condition of the only chest wall. So, in this condition, if I measure a pressure difference between inside the thoracic cavity and outside the chest wall, so this pressure difference, this is a trans pressure. So, what will be the name of this trans pressure? So, in between these two pressure zone, which structure is there? Thoracic wall is there. So, this pressure will be known as the transthoracic pressure. So, when the transthoracic pressure is 0 millimeter of mercury, because inside pressure is also 0, outside pressure is also 0, because both of these pressure are equilibrium with that of the atmospheric pressure. So, transthoracic pressure is 0. What is the resting volume of the only chest wall? That is 70% of the TLC. Getting my point? So, if I have to explain, if I have to draw in this graph, so what I am going to do, I am writing here. So, transthoracic pressure. So, in the transthoracic pressure is 0 millimeter of mercury. Okay, the volume of the thoracic wall is 70% of the TLC, and from there, if you increase the transthoracic pressure, the chest wall volume will increase more. Okay, chest wall volume will increase further. But if you decrease the transthoracic pressure, or if you causes negative transthoracic pressure, the thoracic volume will decrease in this direction, and the minimum volume that is possible with only thoracic or chest wall is the residual volume. So, as you find out here, so this black color curve means this is only chest wall curve, only chest wall curve, right? So, only chest wall curve and the lung and chest wall combined curve, both of them are touching the residual volume, means a minimum volume that is possible with only chest wall or both chest wall and lung intact, that is residual volume. But when you remove the chest wall, only lung can go up to a very low volume, that is the minimal volume, and this minimal volume is how much? That is approximately 500 ml. Got it? So, all these three curves, they are basically the compliance curve. You will understand this compliance concept later on, but from this transmural pressure concept, you have understood that three different structure, when lung and chest wall both of them are intact, when only chest wall, and when only lung, all these three structure, they behave differently. They behave differently. So, this kind of curve, this kind of diagram is very, very famous for image based question. Okay, how to identify the curve? First, you look at where this 0 trans pressure is 0 means, okay, so the curve is cutting this y axis at which point? If the curve is cutting this y axis at FRC, that means that is the combined lung and chest wall curve. If the curve is cutting the y axis at very low volume, minimal volume, then that is only lungs curve, right? And if it is cutting the y-axis at 70%, it is little lesser than that of the TLC, then that is obviously the only chest wall curve. So with this concept, you can understand that the volume and pressure, if you changes the transmodal pressure, how the volume of lung, chest wall or only lungs is going to change. Okay, so this is also known as compliance curve. You will understand later the concept of compliance. So this same curve has been given in books in this manner. So as you can find out here, so this brown color curve, so this brown color curve, as you can find out, this is the curve of only and only, okay. So this is a curve of what? Tell me. So this is only and only lung curve, okay. So this curve is the only and only lung curve, okay. Then you are finding out that this curve, it is cutting at FRC. So this is the lung and chest wall curve. This is the respiratory system curve, that is lung and chest wall curve, okay. And the other curve, this is the curve of only chest wall curve, okay. If you look at here, it is cutting the y-axis at 70% of the TLC. So this way you have to identify the different curves, okay, right? Okay. Now whatever so far we have understood, we are assuming this condition, we are understanding this condition with this simple diagram. So when the lungs are in resting condition, the volume which are present inside the lung is FRC. From there, the maximum expansion of the lung and chest wall that is possible is TLC, and the minimum, okay, compression that is possible is the residual volume. But you all know that when there is full collapsed of alveoli, okay, when there is full collapse of alveoli, okay, then certain amount of volume will still remain inside the alveoli. And what is the name of that volume? That is minimal volume. So as you can find out in this diagram, the balloon is completely collapsed, but still some air is still there inside this balloon, right? And that is the behavior of the alveoli also, that even although it is fully collapsed, but still some air will be present inside this alveoli, and that air is minimal volume. Got it? So this is very important concept in mechanics that you have to understand. Now after understanding this concept, there is a kind of summary. So summary about this FRC, because this FRC is a very important topic. So volume which remain inside the lung after normal expiration is FRC. Trans respiratory pressure, when it is 0, the volume which present inside the lung is FRC. We have already discussed trans respiratory pressure is 0. What is the volume inside the lung? That is FRC. Elastic recoiling of the lung and elastic recoiling of the chest wall are opposite but equal at FRC only. So that is the third point. And FRC is also known as the relaxation volume of the lung or resting volume of the lung. Resting volume of the lung. Never forget this, is very important for MCQ. And when the FRC lung is at FRC, the interpleural pressure is minus 2.5 millimeter of mercury or minus 5 centimeter of water. Okay, sorry, this is water. And in this cases, the intra-alveolar pressure is 0 millimeter of mercury. Got it? So this is the summary of the mechanism that we have understood. Now we are going to understand the simple mechanism of inspiration and mechanism of expiration. Very simple. So to understand this mechanism, just try to look at the same diagram. So this is the alveoli along with this visceral pleura, and the parietal pleura is there, and we all know that this parietal pleura remain attached with this diaphragm. Okay, so this is the diaphragm, with that the parietal pleura is attached. And if I ask you what is the main muscles of inspiration, the main muscles of inspiration is the diaphragm, okay, which is responsible for 75% of the inspiratory effort, and external intercostal muscles are also there. Intercostal muscles are also there, which is responsible for 20% contribution of inspiration. Now you all know that during inspiration there will be contraction of the diaphragm and there will be contraction of these external intercostals. So if the diaphragm is contracting, then what will happen? The diaphragm is going to move in the downward direction. So diaphragm will move in the downward direction if there is contraction of the diaphragm, right. So whenever the diaphragm is moving in the downward direction, along with the diaphragm, what will happen? Along with the diaphragm, the visceral pleura is also going to move in the downward direction. Okay. Now, whenever the visceral pleura is moving in the downward direction, look at the volume of this, look at the volume of this intrapleural space. What is happening to the volume? The volume is expanding. So, now I am writing here during inspiration, okay, during inspiration, there is contraction. There is contraction of diaphragm, okay, and contraction of the external intercostal muscles, and because of this contraction, what is going to happen? There will be expansion of the intrapleural volume, easy, very easy. So there will be expansion of the interpleural volume, the interpleural space volume is increasing. Now tell me, I told you that intrapleural space is a closed space, so the PV is equal to constant, that is the Boyle's law will be applied. So if the volume expansion is happening, okay, what if the volume expansion is happening, what is going to happen for the pressure? So in these cases, the intrapleural pressure is going to decrease or reduced. So intrapleural pressure, normally it was minus 2.5 millimeter of mercury. So if I take one inspiration, what is going to happen? Just now we have understood that because of the expansion of the interpleural volume, there will be decrease in the interpleural pressure. Decrease means normally it was minus 2.5 millimeter of mercury. Now it will decrease further, means the interpleural pressure will be more negative. Interpleural pressure more negative means how much it will be? Minus 6 millimeter of mercury. This is very, very important for MCQ. So during inspiration, intrapleural pressure become more negative. Now I told you already that interpleural pressure is negative. What is the advantage of this negative pressure? Because of the negative interpleural pressure, there will be alveoli will remain stretched, alveoli will remain open. That means this negative interpleural pressure, that is a kind of stretching force on alveoli. So if the pressure become more negative, so there will be more stretching on alveoli, so there will be stretching on alveoli, so that will leads to stretch on alveoli. Okay, stretch on alveoli. Stretch on alveoli means there will be expansion of alveoli. Now whenever there is expansion of alveoli, so normally intraalveolar pressure was 0 millimeter of mercury. Now the alveoli is expanding. So expansion means volume is expanding. So what will happen to the intraalveolar pressure? So stretch on alveoli means there will be expansion of alveoli. Expansion of alveoli means intraalveolar pressure will be decreasing. So intraalveolar pressure decreases. Decreases means it was at 0 millimeter of mercury. It will decrease means it will go below 0 millimeter of mercury, means it will be negative pressure. Negative pressure means how much? Minus 1 millimeter of mercury. So please note down that during inspiration, intraalveolar pressure also becomes negative. And how much negativity? Only minus 1 millimeter of mercury. Now if the pressure inside this alveoli is negative pressure, what is the concept of negative pressure inside alveoli? Negative pressure means this pressure is below atmospheric pressure or more than atmospheric pressure. So this pressure is below atmospheric pressure. So atmospheric pressure below, okay, means the air which is there inside the alveoli, it has more pressure than that of the alveolar pressure. So the air will enter inside the alveoli. So whenever the intraalveolar pressure is negative, this will leads to entry of air inside the alveoli, and entry of air inside alveoli is nothing but our inspiration. So getting my point? So whenever your intraalveolar pressure is becoming negative, the automatically the air is entering inside your lung, because to equilibrate the pressure between atmospheric pressure and alveolar pressure, the air is entering, and that entry of air is nothing but your inspiration. Now if I ask you that how long this entry of air will continue, okay, so end of inspiration means end of inspiration, when this inspiration will stop, or how long this entry of air will continue. We all know that this entry of air will continue until and unless there is equilibrium of pressure, means whenever your intraalveolar pressure is 0 millimeter of mercury, that is the point where inspiration is going to end. Got it? So the bottom line is that during inspiration, the interpleural pressure is becoming more negative, intraalveolar pressure is becoming negative, and because of the negative intraalveolar pressure, the air is entering, and at the end of inspiration, again the intraalveolar pressure is coming back to 0 millimeter of mercury, that is the resting condition. Got it? Now, if you look at the expiration mechanism, now it will be very easy to understand. So, expiration means normally we know that this process is a passive process, because only there will be relaxation of the diaphragm, okay, relaxation of the diaphragm and the external intercostal muscles, right. Forceful expiration is different, but if during normal expiration, it is nothing but the relaxation of the diaphragm. So, whenever the diaphragm is relaxing, look at the mechanism here. So, diaphragm relaxing means diaphragm will move in the upward direction. Whenever the diaphragm is moving in the upward direction, it will causes compression of this interpleural space, followed by it will also causes compression on this alveoli. So, alveoli at the end of inspiration, it is expanded and the pressure inside this alveoli is 0 millimeter of mercury. Now, because the diaphragm is moving in the upward direction, it is causing compression on the alveoli. So, I will write down here that during expiration process, okay, because of the movement of the diaphragm in the upward direction, there will be compression on expanded alveoli. And whenever there is compression on the expanded alveoli, what will happen? There will be reduction in the volume of the alveoli. So, the pressure was 0 millimeter of mercury, now you are causing reduction in the volume. So, reduction in the volume means what will happen to the intraalveolar pressure? The intraalveolar pressure will increase inside the alveoli, and it will be how much? Plus 1 millimeter of mercury. Now, we all know what is the meaning of this plus pressure. Plus pressure means this pressure is more than that of the atmospheric pressure. Whenever this pressure is more than that of the atmospheric pressure, this will leads to exit of air from alveoli. Okay, exit of air from alveoli is nothing but your expiration. And now, if I ask you the same question, that how long this exit of air will continue. So, end of expiration means again your intraalveolar pressure will return to 0 millimeter of mercury. Got it? So, this concept sometimes is plotted with the help of this curve. So, look at this graph. What is this? So, these are the three lines made. Okay. So, the x axis of this graph is the time axis and y axis is the pressure axis, right? So, time means the time difference between these first two lines. This is the time duration of inspiration. So, during inspiration, okay, what is happening? We are going to plot here, and the time difference between these later two line, this is the time duration of expiration, right? And here it is written that intraalveolar pressure and interpleural pressure, how they are going to change. So, when you are beginning the inspiration, so this first line is the beginning point of the inspiration, then next line is the ending point of the inspiration and the starting point of the expiration also, and the third line is the end of expiration. So, this intraalveolar pressure in resting condition, this is 0 millimeter of mercury, but whenever you take inspiration, we have seen just now, we have seen that intraalveolar pressure will be negative. How much negativity? That is minus 1 millimeter of mercury, that is maximum. And at the end of inspiration, again it will return to 0 millimeter of mercury. Try to look at this curve. So, this curve indicates this is the change of intraalveolar pressure. So, during inspiration, it is becoming negative, and at the end of inspiration, again it is becoming 0 millimeter of mercury. What will happen during expiration? It will become positive, and then at the end of expiration, again it will be 0 millimeter of mercury. So, this typical curve is nothing but the intraalveolar pressure change curve during inspiration and expiration. Getting my point? So, the maximum negative intraalveolar pressure at the middle part of inspiration and maximum positive intraalveolar pressure at the middle part of expiration. Getting my point? And how this intrapleural pressure is going to change? Interpleural pressure normally in resting condition is minus 2.5 millimeter of mercury. We have just seen that inspiration means this intrapleural pressure will be more negative. So, it will go into more negative condition. So, from minus 2.5 millimeter of mercury, it will go for more and more negativity up to minus 6 millimeter of mercury. And then during expiration, this pressure will return to the resting condition again like this. So, this pressure is again returning to the resting condition during expiration. Getting my point? So, The bottom line is that this intrapleural pressure is never becoming positive during normal breathing. During inspiration, it is becoming more negative, and during expiration, it is returning to the negative resting condition. And intraalveolar pressure, during inspiration, it is becoming negative, during expiration, it is becoming positive. Got it? So, this is the normal breathing cycle, but there is a condition where you do a forceful expiration against a closed glottis. What is the name of that maneuver? That is known as the Valsalva maneuver. So, during Valsalva maneuver, because you are doing forceful expiration against a closed glottis, the intrapleural pressure become very positive, and that can reach up to maximally 100 millimeter of mercury if the build of the person is very large build, means if the muscles of the thoracic cavity are very strong. Okay, and there is another maneuver that is known as the Mueller's maneuver, that is forceful inspiration against a closed glottis. You are taking deep inspiration. So, inspiration means interpleural pressure will be more negative. So, normally it become minus 6 millimeter of mercury, but during Mueller's maneuver, it can go up to minus 80 millimeter of mercury maximally. Getting my point? So, more positive pressure, more pressure on the thoracic cavity, interpleural pressure can become positive. Okay, but for normal breathing, it is not becoming positive. It is giving more negative and then returning. But if you give huge pressure on the thoracic cavity, it can go up to positivity. And how much positivity is possible? During Valsalva, it can reach up to plus 100 millimeter of mercury. And same way, if we do a deep inspiration, then interpleural pressure will be more negative, and maximum negativity that can be created by Mueller's maneuver, that is minus 80 millimeter of mercury. So, this is all about your understanding of mechanics of respiration. Now, we are going to do few MCQs. So, the first MCQ, efforts is the volume of the lung which remains in the lung after, I told you repeatedly that after normal expiration, got it? So, this is the first answer. Relaxation pressure is 0. Relaxation pressure is 0 when the elastic recoiling force of the lungs and thoracic cavity are opposite to one another but equal to one another. That is at which lung volume? That is at FRC. So, FRC is the answer of this question. Okay. Then what does the zero trans respiratory pressure? Repeatedly I told you, zero trans respiratory pressure means that is nothing but functional residual capacity or FRC. Got it? And the last question, if the lungs was allowed to recoil without the chest wall, means it is nothing but removal of chest wall. So, if you causes removal of the chest wall, we have already understood the lungs are going to get fully collapsed. Even after full collapse, certain volume still remain inside the lung, and that is approximately 500 ml, that is known as the minimal volume. So, this is all about mechanics of respiration. Thank you.